Okay, start. Um, Welcome to GRAMOLY. This is FIZIKA 2021 guest talk with Dr. Bernard Ricardo. First, I'd like to tell you some details about GRAMOLY. It is a non-profit organization promoting natural science fields. And regarding FIZIKA, it was an annual physics challenge held by GRAMOLY with over 5,000 participants from 50 different countries in its first year only, making it one of the biggest online physics competitions held across the world. Now, today our guest is Dr. Ricardo. You may know him as the author of Competitive Physics. He is also the coach of Singapore International Physics Olympiad team and a senior consultant at NUS High School of Mathematics and Science. He has also authored several research papers. And I am Nimarjeet Singh Bajwa, the host for today's talk. So my first question to you is, what ignited your interest in physics and were you always interested in it?
Hi, Nimarjeet. Nice to meet you. All right. Yeah, I think first of all, I would like to say that I'm really honored to be invited for this talk, and thank you so much for hosting this. Okay, this is really a great platform to get everybody, all the students especially, to be interested in physics, and in natural sciences in general. Yeah, what ignited my interest in physics? Um, if you ask me, was I always interested in it? My answer will be no. I was not always interested in physics. I think I may share some unique experience and embarrassing experience actually with my physics teacher at junior high school, as they remember that. Because during one of the physics experiments, my teacher spilled boiling water onto my private part, and I was really rushed to the hospital. And of course, thank God, nothing serious happened. But that was really a life-changing experience for me because that made me hate physics, and my physics teacher definitely. So I can say that my hate for physics was manifested in me in wanting to surpass my teacher. So actually, that was really a turning point. Yes, I have had this very unique experience. So I kind of realized that physics was fun and it could be found in all aspects of life. And, in a sense, like by asking simple questions on things around us, we could learn physics concepts. I mean, by just looking at things around us and stuff, they are all essentially physics. So, in a sense, I began to cultivate interest over time. It was really not immediate. And that's how I began my journey. Yeah. I hope that answers the question.
That's very interesting. And
It
did
was.
any part of physics interest you more? Like, were you more interested in mechanics or circuit analysis?
You mean topics?
Yes.
Yeah. Well, I honestly don't have strong preference against any of the topics in particular, but I took my undergraduate in electrical and electronic engineering. So I find circuit analysis enjoyable, definitely. But I also like other topics like mechanics, specifically like central force, rotational mechanics, all these kinds of things. So, in particular, I can say that I like to see how mathematics plays an important role in understanding some physics laws or concepts. You know, I like to see that physics gives meaning to that bunch of formulas. Yeah, so topics that require more mathematics generally interest me the
Oh.
most. Yeah.
And we also read that you got your PhD in physics teacher education.
Mhm.
So, would you like to tell us about your teaching methods and why do you feel that they are so effective?
Why do I feel that they are so effective? Well, just to clarify, my PhD is actually in physics. However, I mean, it is under physics department. However, my research topic touches, it straddles on both content and pedagogy. So it touches physics education aspects in a sense. And the unique feature of my research is the blending of theoretical physics and physics education research. And the main theme is on promoting mathematical thinking on in physics. So this is I mean, there are a lot of jargons over there, of course. So I would say that I don't have certain techniques or some powerful pedagogy teaching approach that is effective for teaching physics. But from what I discovered in my research, I realized that the students' articulation of mathematics students, in a sense, they really perform highly. They score very well in all tests and exams, including physics. But somewhat, my research actually has shown that these students, these high performing students, they have difficulties in articulating their mathematical thinking. So, yeah, so something that, in a sense, something that motivated my research. My colleagues, there are some other physics teachers that say, they try to delink between mathematics and physics. They try to say that, look, if we want to teach physics, we should teach physics and not teach mathematics. So they are going to say something like, we should teach physics first, and then after the students understand the physics, then we can teach the mathematics. Well, I totally disagree with that, because they fail to see that mathematics is the language necessary to understand physical phenomena. And of course, one of the aspects in my research is also the finding of the strong correlation, strong positive correlation between the extent of students' mathematical thinking and their conceptual understanding. So it is not just about their performance in the test, but also in their conceptual understanding of certain physics concepts. And if you see, like, some historical, I mean, facts, in a sense, many well-known physicists such as like Isaac Newton, Archimedes, Feynman, Maxwell, Albert Einstein, they are all mathematicians themselves. So I believe that mathematics is an intrinsic component of science and is part of its fabric. And reciprocally, science inspires and stimulates mathematics. So very often, new physics and new mathematics go hand in hand. So my strong motivation to pursue my PhD was because as a physics teacher, I saw that this element of mathematical thinking was indeed missing or overlooked in high school physics. So, research says that for example, there is a decline in the number of students pursuing physics in the university. And one of the factors is because they feel that the mathematics is too hard. And as a reaction to that, I wouldn't say it is a response, it is a reaction actually. Educators try to make mathematics as a subject easier so that the students can feel more confident. And you know and for the conceptual teaching of physics, they avoid the mathematics in it, which I feel that it is not addressing the issue at all. You understand what I'm saying? So that is
Yes.
really off the mark. So it's like they are not addressing the main issue over there. So when we talk about mathematical thinking, this is really a crucial element which I feel that students have to have it, have to be trained in it from the very beginning, from their early years. So again, I wouldn't say that I have unique teaching methods. I wouldn't say that I have very special approaches, that are so effective in teaching my students. I would say that I have unique teaching philosophy, because I think it is important for students to have early exposure to mathematical thinking when studying physics, even from the simplest topics. So there is really nothing wrong in introducing the mathematics early when teaching physics concepts. In fact, students would be empowered to perform deeper analysis of a physical situation and in turn perform better in assessments. So they will also appreciate to see the connection between the two subjects. So this is what motivated me to pursue my PhD. Yes, it is under physics because I did some content as well, content research as well. But in a sense, okay, I used the content that I created to do research, to do educational research. Yeah, that is what I can say.
That is a very interesting find. And
Mhm.
So, how do you believe that one can generate curiosity regarding physics in the younger students? Because, as you said, mathematics can obviously deter the younger students.
Yeah, well, for me myself, okay, because when I see, like, for example, if there are physics teachers who are trying to avoid mathematics when teaching physics, with the belief that, hey, mathematics is going to, push some students out, push some students away from taking physics, from learning physics. I totally disagree, because for me, mathematics actually fascinates me. It is something that gives me this fascination towards what is happening around me. And here is what I found fascinating. It's like, most people who like physics are fun people, at least the one that I've been the ones that I've been seeing around me. I mean, they are all fun people, they are not boring. I hope you agree with me with this.
Yes.
Yeah. And like, legend has it that Newton discovered gravity while sitting under an apple tree, right? I mean, not even in his study room or at the library, you see? So this is the story that I always tell my students. So it's like, even by sitting under a tree, you can discover something. You can just see the things around you and discover something. So we don't even know what Newton was doing over there. And Archimedes discovered the law of buoyancy while taking a bath. I
Yes.
mean, how many of us can discover something when we are taking shower, right? So all these famous physicists discovered something by observing things around them and asking questions, definitely. So I will say that if we really want to generate curiosity in ourselves, well, start by asking questions. Start by looking at things around us and ask questions. I think, yeah, that is what I can say. It's like, you know, uh, since childhood, I think I've tried to ask questions about anything and everything under the sun. It's like all the things that go around me. Why is it like this? Why is it like that? You know, yeah. I guess that is what generates and cultivates curiosity in myself. So I believe that you know that also works for other people as well.
And so, why did you become a physics teacher after your PhD? And why do you continue teaching it as well?
Well, why
Well,
did I become a physics
why did
teacher?
I become a physics teacher?
Um, this is a tough
This
question.
is
Why
a
did I
tough
choose my
question. Why did I
career
choose my
as a
career
physics teacher?
as a physics
Uh,
teacher?
I have a very interesting
I have a very
story, actually.
interesting
Just
story
now, just
actually.
now,
Just
the
now,
first
just
story was junior high school. Okay, now is senior high school. Okay, well, so when I was a student in my senior high school, I was so naughty. Okay, so I never listened to my physics teacher. Actually, I mean, I told you that you know physicists are fun people, right? So they are
yes.
not boring. So yeah, I never listened to my physics teacher. Actually, I never really studied. And I remember that one day I just kept on talking with my friend, and during one of the lessons, and my teacher just stared at me, and she said this: "Hey, you think you're so smart? If you think you're so smart, come up here and teach the class." So, and again, that became a life-changing experience for myself. It's like she asked me to be a teacher for one day, and she said, "Yeah, be a teacher for one day, and you will realize how difficult it is." And true enough, in a sense, I substituted her that day, and I discovered that it was so difficult in teaching, but I ended up finding fulfillment in teaching physics. I ended up realizing how enjoyable it was in imparting knowledge to others. So yes, a lot of people actually ask me, why don't you just become a researcher or do some other things? But I feel that no, I should really pursue my passion, and my passion is really for teaching. So I realized that this is where I'm good at, and yeah, so that this is something that I like to do. This is where my passion is. Yeah.
So, in a sense, delinquency led you to become a physics teacher.
Yeah. So yeah, in a sense, I really understood the feeling of my physics teacher that day, and in fact, I'm still in contact with her until now. So I realized that This is really where I'm supposed to be. All right. So yeah, and believe it or not, this is actually my first job. Yeah. So I've stayed in this for, I don't know, 15, 16 years already.
You also wrote two books regarding competitive physics.
Mhm.
So, what inspired you to make out time from your busy schedule to write these books?
To make out time, the books are actually with me right now. Okay, so uh, well, if you ask me in general, I don't have that much of, of a time. Well, yeah, my co-author, Mr. Wang Chinhui, actually, he used to be my student in the Singapore Physics Olympiad national team. He's an amazing, humble, and intelligent guy, I can say. So since we both were physics Olympiad students before, so we kind of know about what the students need to learn during their preparation, especially as they are preparing for physics Olympiad competitions, right? Usually the Asian Physics Olympiad, the International Physics Olympiad, and stuff. So for the competitive physics books, we should really give the biggest credits to Mr. Wang Jinhui, actually, my co-author. My contribution is in putting the educational angle in the content such that the books can be easily used by students. All right. So I also contributed in some of the questions in the sense, that will really enhance the students' understanding in the concepts that they just learned within that chapter. What inspired me to write the book, to co-author the book? I've been training physics Olympiad students in Singapore since 2006, and I always relied on my experiences in physics Olympiad. In a sense, in the past, I actually went into the class just bringing one marker, and I didn't bring any resources. I didn't bring any materials. I just explain some concepts to my students. I just give them the questions that I could think of. So one day I was just thinking whether I should put everything into written form so it could benefit more people. Yeah, I had been thinking about it for a number of years actually. So this Wang Chinhui was actually my student a few years ago, and he approached me about this project. He asked me whether I will be willing to co-author with him. And after sharing with me, it indeed resonated with what I had always had in mind. And there we go. We have the books. Yeah, and I do hope that the books can really help, the students out there. Yeah.
And what would be your way of going around using your books to prepare for a physics Olympiad like IPhO?
Well, the books actually address the concepts required for physics Olympiad, as well as some questions that make use of those concepts. So of course, I don't deny that there are other books out there that provide more questions and in fact more advanced questions as well. But again, from the pedagogy perspective, I do believe, of course I am biased. These are my books. So of course I am biased, but I do believe that competitive physics books can provide better scaffolding for students who want to prepare for physics Olympiad. Yeah, so yeah, I believe that it will be helpful.
Um, we have also noted that you published many research papers regarding physical concepts like the
Well,
three-axis
it's not
theorem
many.
and the squashing method.
Yeah.
Have you always had an interest in these research projects? Or
Um, have I always had an interest in research projects? Yeah, well, actually, this research is intertwined with my PhD research on promoting mathematical thinking. To me, it is really fascinating to see that applying deep mathematical thinking into certain physics concepts can actually result in some interesting phenomena. Of course, mostly I'm dealing with theoretical phenomena instead of experimental, as well as to discover some new methods in approaching something. Like, for example, if we just take the concept of moment of inertia in rotational mechanics, like applying deep mathematical thinking into this concept of moment of inertia would yield new creative methods or new creative approaches in computing moment of inertia for rigid bodies. So, well, I'm a teacher still. I'm not a researcher. So, research is not my specialty, I would say. However, I really consider it a privilege that I'm able to do some content research as well as educational research at the same time, you know. And sometimes it simply arises from my casual interactions with my students, really. So, just talking with them, and sometimes the idea just simply pops out and it becomes a research idea, which we will engage ourselves for 1 year, 2 years, and to really produce something. Yeah, so I consider it a privilege, really.
And some of these papers were also published with student researchers, right?
Yeah,
Like
some of
Nitesh
my
Savanan.
students. Yeah.
So, yes, how do these students go about approaching you for help with these projects? Or how does it work?
Well, as I said, sometimes it arises from casual interactions. So something just comes out to my mind. I ask my students to think of it. It may take them 1 to 2 years actually to get back to me, and then we write together. Like I still remember, like there was one student which one day I just texted him, "Are you free?" And he said, "Yes, I am. Is there anything?" So he was scared because the teacher was calling him. So he might have thought like, I'm in trouble or something. So I just asked him to come, and we just sat down together, and I told him, "Look, there is something that has been bugging me about this concept. For example, the concept in central force." So I told him, "Yeah, is there anything that you can do about it, because I might not even have that luxury of time, to spend so much of my thoughts, into thinking about this." Then my student said, "All right, yeah, sure." And actually it took us, I think, 1.5 years to really come together and talk about it and put everything into writing and publish the paper. um, the student that you mentioned just now, Nitesh, he yeah. So I also had this some idea, and then I talked to him, and then he was like, "Oh yeah, maybe I can try to find more examples or more applications, to it." And yeah, and he came to me with his eyes wide open, and he told me like, "Wow, while finding some examples, I actually discovered something new." And that was really what amazed me about these students. So I told him, "Hey, why don't we just put everything into writing? Let us write some research paper together." And he agreed. And again, that is why most of the research papers that I published are theoretical papers. Actually, last year during lockdown, well, while the number of COVID cases in Singapore was on the rise, yeah, so we couldn't do anything. We just simply stayed at home, and the school was closed. And yeah, so some of my students, they didn't know what to do. Well, they had nothing to do. So actually one of them gave me a call and said like, "Hey, uh, do you have some research idea?" And then I said, "Oh, why?" "I don't know, I just want to do it." Because there's really nothing to do. So I said, "Okay." I do have some simple thing actually. Then I shared with her, and she started doing something about it. She started uh, pouring her thoughts, her energy, her effort, into discovering things. And after a few weeks, she actually got back to me and she said, "Wow, I really found a lot of examples, that they are so interesting." And I felt like, wow. and and yes, we published something out of it. So um actually all these I basically all these research papers, right? I encourage all my students to um think about something, think out of the box, apply their thinking. And of course, I do believe in mathematical thinking. So apply deep mathematical thinking into all these physics concepts and try to get some novelty out of it. whether it is a new method, a new approach, or whether it is some examples that we never thought of, all these things. And actually, I have made use of whatever we discovered or whatever we published into my teaching as well. So in a sense, for my physics class, I actually teach them about all these new methods, for instance. Yeah, and that is quite fun.
And how do you think a high school student can start research in physics? Is it just by asking questions? Like, there must be some mathematical backgrounds as well. And are there any utilities that are necessary to start the journey in physics research?
How can a high school student start research in physics? Um, yeah, actually, you just answered that. Albert Einstein, there is this famous quote by Albert Einstein. I think you guys might have heard of it before. The important thing is not to stop questioning. Curiosity has its own reason for existing. Yeah. So the very same reason why I love physics, how I learn physics, is the same necessary trait for students to start their research journey. So I always encourage my students to think creatively, whenever they face a problem and come up with something novel out of it. Okay. So whatever kind of research that they do, if no matter how simple it can be, the main factor that I would ask them is, okay, so what is the novelty in it? What do you contribute? Is it just, are you just simply repeating whatever work that people have discovered before? Have you really put your thoughts into it and tried to think deeply, applied your mathematical thinking deeply? I mean, of course, our context is physics over here. So, yeah, the most important thing is not to stop questioning. I guess that is how you embark on a research journey.
And you also teach computational physics in US high school. Is that
Oh,
right?
how much did you guys taught me? Wow, you you know everything. Yeah. Yes, that
And
is true.
what piqued your interest in computational physics as a field? And do you think that it has a lot of utility in physics research as well, computational physics, that is?
Um, well, I, I I do have some programming background. Um, I think many years ago when I was in primary school, I learned Q Basic. Some people may not even have heard of it. Um, yeah, in my undergrad, I learned C++ and Java. And to be completely honest, I only started this computational physics module in the school last year. So, because some of us in the physics department talked about this idea, we want to start this computational physics module, and not many teachers are willing to take a big step in actualizing it, in embarking into the journey. So I was like, okay, let me do it. So I started learning Python at the beginning of last year. Actually, I took some courses, online courses in Coursera, in DataCamp. I started this computational physics module in the second half of the year then. So yeah, that was actually last year, and that was purely because of COVID, because of lockdown as well. So actually, this COVID brings a blessing to me, So, and I really think computational physics is very useful and helpful when we want to predict or simulate what really happens in real life. Sometimes it is just too difficult or even impossible to come up with analytical solutions as we know it to describe the behavior of a physical system, especially when it is very, very complicated. So computational physics, even though it is not accurate, of course, but it gives us a sense of predictions of this behavior. I think that is useful. If you ask whether it has a lot of use in physics research, I believe so. I mean, even though I have not really used it per se for my research, because I only embarked on the journey last year. So, but I believe so. There are so many interesting physical phenomena around us. In fact, in my computational physics module, I asked my students to embark on a research journey as well, like just a small research component. Uh, but they really amazed me. They never fail to amaze me. So they came up with so many physical phenomena that somehow they just used this computational physics. We all use Python, to describe about the behavior of physical system, various physical system. Yeah. So whether it is planetary motion or even Atwood's machine or yeah, whatever it is, but yeah, there are just so many interesting physical phenomena around us, like bungee jumping, all these things, and they just used Python to model everything, and uh, they came out with the simulations as well, and that was really amazing. That was interesting. Yeah.
Any particular simulation which you found extra interesting, which would you like to share with us? Uh,
Well, uh, I guess okay, there was this Atwood's machine, okay, whereby they just simulate two masses connected with pulley, so it is just a pulley system. But then now the masses are swinging, okay, so
oh,
they are given some initial conditions, some initial positions and angular velocities as well, and at the same time the length of the string connecting them may change. So of course it is very complicated system in a sense if we want to solve it analytically, right? But they really programmed everything. They came out with the simulation as well. So what happens when the angle is too large? What happens if the mass is too large, and so on and so forth. So when I see all the simulations, we key in all the uh, various initial conditions, and all the interesting, not just phenomena, but patterns. Interesting patterns actually appeared from such a system, which at the beginning, I didn't even think that there would be a pattern. Yeah. So from this kind of thing, actually, that gave us some insights. And in fact, if we want to proceed further from that, we can just pick up, from where we left off. And in a sense, let us really analyze this system, you know, using our deeper mathematical thinking in a sense, and I believe that something interesting can come out of it. Yeah.
and and do you prefer using Jupyter Notebook and programming-based computational physics, or do you think like something like Mathematica is enough for?
Personally, I'm currently using Jupyter Notebook. Yeah. Because simply because I'm used to it. So I think it all depends on the preference of the user. Yeah, I know some people who prefer to use Mathematica, to solve all these things. But yeah, for me personally, I prefer Jupyter Notebook.
And as an IPHO trainer as well, what has been your experience training students in competitive physics?
You mean in computational physics, or
No, no, competitive, like for Olympiads.
for Olympians, for IPhO? What has been my experience? Well, I've okay, I've been involved in this IPHO training since 2006, I believe. Yeah, that was a long time ago. And yeah, so I've been training the national team. What has been my experience? The experience has been quite interesting because I can see, like, the moment all these people come together, because they are selected from their school, and of course they are like a bunch of the best students across the country. I think it is really interesting to see people with the same heart and mind, who really love physics so much, have passion for physics, and they come together to discuss about a lot of problems. I think I would say that it is not just them learning from me, but I'm also learning from them, because sometimes there are just a lot of questions or concepts that they brought it up, and then we discussed together, and I really learned something out of it. So yeah, the experience has been quite fruitful to me.
And training IPHO students.
How did I begin? Well, because I was a former Olympiad student before, so okay. Originally, I came from Indonesia actually. So at that time, I represented Indonesia in the Asian and International Physics Olympiad. That was in 2003. So yeah, I was a medalist, and from there, then I got a scholarship to study in Singapore, and I took my undergraduate in Singapore, and yeah, I've been staying in Singapore ever since. So yeah, and from there, I was like, yeah, even though I took engineering, but somehow my heart is always for physics. So I felt like, hey, I really want to find some challenge. I want to, and as I told you before, I really love teaching. So I tried to find some opportunities around me to teach physics. And actually, my friend suggested to me like, hey, why don't you try to find this physics Olympiad team for Singapore, and probably they can engage you. So I was like, yeah, that might be true. And I tried to contact them. And actually, at that time they didn't really have a fixed trainer in a sense. Yeah, so that was how I began actually. So I started training the team, and from there I've been training the team every year until now. Yeah, and sometimes they also send me as a leader for the competition for the Asian and International Physics Olympiad as well. Yeah.
And can you also take us through your journey on how you got a physics medal or how you became a Olympian?
Well, okay.
Because you said you didn't like
Yeah,
physics in the
you
middle
are
school.
right. Yeah, but again, that really manifested in me wanting to surpass my teacher. So I tried to read some physics books, outside the school curriculum, and I discovered that physics was really fun and enjoyable, and it was so interesting because it really happened around us. Now, um, I don't know. It's like I feel like at that time, even when I see just a simple thing, when I see a fly, just a small fly flying around me, when I was inside a car, I began to ask myself this question: hey, something is wrong. Because the car is moving forward, how come the fly can just fly around me? I mean, how come the fly is not flying backwards? So this is just a very simple question, that I asked myself, and I still remember it until now. I was like, oh yeah, why is it like that? So from there, from that simple question, this is just an example. From that simple question, I began to ask myself, like, how does a fly actually fly? What are the physics principles behind it? You know, and what would happen if there is no air? What would happen if I drive the car on the moon and not on the earth? And so on and so forth. So there are just a lot of things that we can discover, a lot of concepts that we can learn out of a simple phenomenon that we observe. So I really think that physics is really everywhere. It is really everywhere, So all those concepts like mechanics, the aerodynamics, everything, So um, yes, I hated physics at first, and because of my physics teacher in senior high that asked me to teach the class that day, I felt like, wow, I found my passion in teaching physics, and I felt like, okay, I should really learn deeper. So I always tried to learn on my own. All right. And yeah, and that was the beginning where I started participating in physics competition, physics Olympiad in particular. And because my country Indonesia is very big, so they have a lot of different selections all the way to national level. So yeah, so I participated in all those, and yeah, that was how I got selected, all the way to the national team, and then represented the country for the Asian and International Olympiads. And yeah, that and from there actually I felt like, yeah, this is really my life. physics is really my life. Yeah, I can never run away from it. Even after taking, I tried to run in a sense, run to engineering, and I felt like probably there is not much physics in it. But I ended up missing physics even more. So actually, after my undergrad, I straight away um, took my master's in physics, and after that, PhD in physics as well. Yeah,
And you have been training IPHO students for 15 years now.
yeah.
Would you like, if are there any changes that you would like to see in IPHO today in terms of syllabus or format?
In terms of curriculum, I think it's already good because it covers quite a broad topics in a sense. But personally, I have some concerns regarding the format of the questions. Well, this is my personal opinion because it is getting more and more like undergraduate exam papers. So in a sense, even for one question, there is part A, B, C, D, E, F, G, H, I, J, even sometimes, all the way. Like, I feel like they try to scaffold the questions. Like part A, maybe ask something easy first, and then something that leads to part B, and then something that leads to part C, and so on and so forth. I would prefer the early years IPHO, where the questions require the students to do some kind of design thinking, because the students should really come out with the approaches, the assumptions, the theory, the formula, and so on their own. So it is not so much guided like the current IPHO papers in the past few years, actually. So yeah, and actually there has been this competition. I don't know whether you guys are aware of it, the European Physics Olympiad. Actually, they tried to get back the spirit of the early IPHO. So yeah, they format the questions in such a way, that the questions are actually very short, but the steps involved for the students to come out of all the approaches, the assumptions, and everything, um, there are a lot of steps actually. Yeah.
And from the love of physics, what is the most common quality you have seen in students which you train for IPHO?
Common quality? Common quality in students. Well, actually, you just give me a research idea for my educational research. I've been wanting to confirm these traits of successful Olympians, actually, you know, because I've been dealing, I told you before that I've been dealing with high performing students. And sometimes I ask myself, what kind of traits are necessary for them to be successful Olympians? Because I believe it is not just because they are smart or they are hardworking, they are diligent. There must be these X factors that I would really love to discover. You know, what are the common traits, the common qualities that these students actually have? Well, for now, I can just tell you my hypothesis, of course. In a sense, perseverance is number one, definitely, because the students should not give up easily when facing a dead end. Especially, we know that Olympiad students uh, will really require students to think and rethink. Sometimes we need to unthink again and rethink about everything again. So yeah, in a sense, perseverance must really be there. Curiosity is the second thing. They should really keep asking questions. They cannot just stop at yay, I finished this question, I solved it and that's it. They should really continue questioning, like, what happens if this happens this way? What happens if this one is too large? What happens if, so they have to keep asking questions. They cannot just stop. And of course, the third one, they must be competitive. I mean, we are talking about competitions, right? So they must be competitive. They should not be satisfied with the current level they are at, because I think, participating in all these competitions made me realize that there are just so many other better physics students out there. So the sky is the limit. I mean, we have to stay competitive at all times, but again, all these traits are just my hypothesis, in the sense that yeah, as I said, you just give me a research idea, so probably I will need to confirm all these traits, via research. That that these qualities are necessary for successful Olympians. Yeah.
Now, let's move on to some audience questions.
Oh,
The
sure.
first question I got is, how do you define problem solving? And according to you, what is the way or how to develop problem solving skills? So the first part would be, how do you define problem solving?
How do I define problem solving? Well, okay, I do believe that when we want to develop our problem solving skills, right, it is not just about solving physics problems, but we have to have targeted problems, at the topics that we are learning. So of course, because I'm a physics teacher, so in a sense, we, when we create questions for our students, we cannot just simply, you know make any physics questions and just, give it to the students. So we have to identify the learning objectives, for example, for a particular topic that we are teaching. So what is the learning objective over there? What do we want our students to learn from this topic? So yeah, the questions, the problems that we want the students to solve, they must be targeted, in the sense, you know at the, not just the topic, but the skills that we want the students to have. Yeah. So in the same way, for the students out there who are preparing for physics Olympiad competitions, especially, well, you need to know, like, what is it that you are developing right now. So in a sense, if you're learning a certain topic, i want I want to find problems. I want to do problem solving right now. I want to find problems that will develop me in these skills. Yeah. And that is why I said there may be a lot of other physics books out there with so many advanced questions. Okay. But I feel that, these competitive physics books, I'm promoting my books again. So, these competitive physics books, they are really targeted. Okay, so we really try to scaffold everything from the topics all the way to the questions themselves. Yeah, I hope that answers the questions. Yeah.
And any methods or you would recommend to develop problem solving skills?
I wouldn't say there are specific effective methods, because the learning style for each student is different. So I don't want to say that, this is the specific method that you should follow, because I do believe even my learning style and your learning style are already different. Yeah. So discover what it is that you like, discover your own learning style, and just go for it. Just do it. Yeah.
Yeah. Okay. And the second question we have is, how to introduce someone to competitive physics? And how do they start preparing for it if he or she has proper maths background and has done topics like calculus and basic algebra?
So so this is about physics competitions, yeah?
Yes.
Okay. So I thought competitive physics means my books over here. So well, yeah. To physics competitions, how do you introduce someone to physics competitions? Well, first of all, they must have competitive spirit, of course. I mean, it is not just about for the sake. I mean, some people say that, oh, I'm learning it for the sake of learning. Well, that is good. Um, but if you don't have competitive spirit, then it's very hard, because you are not going to have this motivation to keep on improving and keep on probing that particular question that you are doing. Yeah. So this is really, um, I think this goes back to my previous answer. You need to keep on questioning. Yeah. Never stop questioning. Okay. That is if you want to really um, start your journey on physics competitions.
The next question we have is,
Yep.
how to prevent demotivation when we aren't able to solve any physics question?
Well, this is motivation issue. Okay. I mean, I got that all the time, man. I went through that all the time. I believe you also did, right? I believe everybody did. Um, well, I think this is how we develop perseverance. To me, myself, I really find satisfaction in solving something, and actually in the middle of doing that, right, I might actually discover something new. This is the novelty that I talked about just now. So it's like you really need to find this fulfillment in the things that you are doing. So if, let's say, for example, okay, you get good grades for your physics test and you just feel normal, just be happy, and that's all. Probably that does not bring you anywhere, I would say. You know, again, the main important thing is, after you master certain skill sets, you don't stop there. You don't be satisfied with the current level you are at, because there are just many other things that you should learn and you should pick up. All right. So I've met a lot of people who are very good in the things that they are doing, but you know that the things around the world are changing right now. In a sense, like all these data science, machine learning, everything, like they are all changing. Now the question becomes, do we want to stop learning right now? Are we just satisfied with whatever we have right now? I suggest that we don't. Yeah, so for me myself, if I have to learn programming, I will do it. Just to cope up with the change around me. If I have to pick up Python, even though probably I've forgotten most of the programming skills that I've learned so far, but so be it. If I have to learn it again, I will learn it. Yeah, so I believe that it is the same attitude that we have towards learning that we should have. So to overcome this demotivation.
Um, Next question now. Time should one spend time thinking about a particular question or do large number of problems in the same time? So I think this is.
We have to strike a balance between the two. Yeah. So, like for example, nowadays all the questions out there, they have solutions provided. Uh, Obviously, I will say that we should not look at the solution straight away, right? So yeah, if you really want to learn something, then you should try to do it yourself. But I would say I am not preventing you from looking at the solutions afterwards. Feel free, because I don't want you to get stuck in certain things, and you keep telling yourself that, oh, that means I cannot do it. That means I'm stupid. That means this is my level. And that's all. I cannot go further from it. Actually, that is really wrong. If you get stuck in something, and obviously if the solution is there, it is already provided, that is okay. I mean, you have tried your best. Just take a look at that, take a look at the solutions, and try to learn from the solutions. What is it that you were missing? And from there, then you move on. Continue with other questions, with deeper questions and more advanced questions. Yeah. So
And
again, strike a balance between the two.
and when do you think it is a solution?
After you have really done your best. Yeah. If you think that that is already your best, then feel free. Yeah. I believe it is different from person to person.
And next question we have
Yep.
is, as a physics Olympiad aspirant, how should I start applying theoretical physics concept to real life applications? And what are physics Olympiad demands? So that is the first question.
Sorry, can you repeat the question
Yeah,
again?
as a physics Olympiad aspirant, how should I start applying theoretical physics concepts to real life applications? I think that is the first part of the question.
Okay. How should we apply it to to real life? Well, a lot of physics Olympiad questions, I, let me just put it this way. A lot of physics Olympiad questions, they are quite theoretical. Yeah. So in a sense, it is a bit different, in the spectrum. In a sense, it is different with physics research, which touches more on real life in a sense. Yeah. So, well, I have nothing against both of them, of course, but as I said, I'm more of a theoretical researcher. So in a sense, yes, we should, I mean, discover what it is that you want. I had a student in the past who said that, I mean, you can imagine, he made it all the way to the national team, and he had the potential to even represent the country for the physics, Asian and international physics competition. But he told me this, look, Dr. Ricardo, can I stop my journey? So I was a bit surprised, like, why? And he said, it is okay, because I've actually discovered my passion, and my passion is for research. So I said, oh, okay. I tried to sit down with him and try to talk to him, and he seemed quite certain about his choice. He seemed quite happy with his choice, and I really supported his idea. And he said, like, yeah, I want to focus on doing research. I want to pursue physics research, and I feel that physics Olympiad does not bring me anywhere, for this dream of mine. So I said, okay, yeah, if that is really your choice, that is okay. So I think the most important thing is for you to discover what it is that you really want to do in your life. I wouldn't say that you know a lot, things in that you learn in physics Olympiad will not be applicable to real life. Of course, of course they will be very helpful. The skill sets are really helpful for you to overcome problems in your life, and not just physics. Definitely. I mean, you can imagine, like, all these, like, perseverance, curiosity, being competitive. Actually, you need all these skills even when you go to the marketplace, and not just for your study, right? Yeah.
And the next question we have is, should one take out time to study some research papers on some standard problems, or just follow the path of preparing for Olympiads?
This is yeah, it goes back to the previous question, actually. In a sense, think about what you really want to do. All right, a lot of people, they really discover their passion for research. And yeah, and a lot of researchers actually don't really like physics Olympiad. Yeah. And to me, just understand what it is that you want to do, what it is that you like. Yeah, for physics Olympiad, again, most of the time it is very theoretical and very mathematical, in a sense. So yeah, even for the experiments, I would say that they are nothing compared to the real research out there. Yeah.
Um, okay, I have one question as well. This
Yeah,
isn't from
sure.
the audience, but what has physics taught you on a moral level? So
On the
for
what?
me, it taught me humility. What has physics taught you, except the concepts, of course, on a
you
moral level?
you mentioned humility, and I
Yes.
strongly agree with that. Yeah. So to me, yeah, I mentioned just now, like, to simply just to realize that there are just many great physicists or physics students out there, who are doing much better, who are much smarter. And yeah, it just teaches me that, hey, even after spending so much time, so much effort into learning all these things, it still doesn't make me a superman. Yeah. So it is really to discover, that is one, of course, but the second thing, it is to discover about about our nature, the things around us. And that really gives us this kind of insight that, wow, there are just so many things in our nature that we have not even discovered yet. Yeah. So in a sense, okay, it gives me an awe towards nature as well. Yeah.
One common problem that some students face, I faced it as well, that after realizing that there are always people better than you can get overwhelmed. Because after working so hard, you still realize, okay, people are doing better than you. So how do you overcome that?
Well, humility is not the same as humiliating yourself. It's not the same as humiliation. So I think that is something where we all have to agree on because, look, the thing is this: it does not mean that you are always worse as compared to other people. You may be better than others at something, but at other things, there are always people better than you. And that is a fact that we have to accept. And that is humility to me. I hope that answers the question.
That is. Okay, next question from the audience is curiosity something inherent or is it something we can build upon? If so, may you explain how?
Okay, that's nature versus nurture.
Yes.
I do believe that it can be built upon. So, um, don't, if let's say you don't have certain qualities in your life and you realize that you don't have those qualities, please don't stop there. Don't just accept your fate. So you should really build those traits, which, you know, I do believe that I was not born with those. You know, there's no, I don't think there's anybody in my family who, who, who loved physics and, in a sense, has this kind of passion towards physics and teaching. But I built over time. And as I said, it was not instantaneous. It was not immediate. I really built it over time. I mean, you can imagine, like, from somebody who hated physics, until someone who loves physics and loves teaching physics right now, it must be built, right? I was not born with it.
And another question we got is what advice would you give to someone who is appearing for the National Olympiad in a few months?
What advice? Keep practicing, man. Buy the book, probably. Well, no, I mean, you should not give up. You know, um, in whatever scenario. Maybe I should share about one experience of mine. I was actually um, okay. I represented the country Indonesia at that time in 2002 for the Asian Physics Olympiad. So Indonesia sent 8 students, and you can imagine, out of the 8 students, 7 of them got something. There is only one student who didn't get anything, and that was me. Believe it or not. So, of course, I was so disappointed at that time, and I was still young, immature, naive, and I thought like that was the end of my life. You see, so I felt like that's it. Probably I'm not cut out enough, for this, and that's it. Probably that is the limit of my brain. So I was like, yeah, there is nothing else I can do. But I stopped there. Fortunately, I really stopped thinking that way, and I told myself, look, if there is a second chance, then why not? So I kept on reading and studying on my own. um, I kept on living my life as per normal, and I was selected again in the following year. So at that time, yeah, 2003. So I was like, I was selected again for the national team, and I represented the country again in the Asian Physics Olympiad, and that was where I got a gold medal. So yeah, so my advice to all the students out there is really to persevere. You should really not give up, um, in whatever situation. A winner does not always win all the time, but I know this, that a winner does not quit. Yeah. So whatever journey that you are embarking on, don't quit. Don't be a quitter. Yeah. So whenever you are facing a dead end, it is not a dead end. Okay, we should keep telling ourselves it is not a dead end. There's always something that I can do about it. I hope that is useful.
last question we got from the audience is
Sure.
the beauty of Newtonian versus Lagrangians versus Hamiltonians. Let's What are the differences and what characteristics do they follow?
Well, um, of course, from the pedagogical point of view, we should really teach the students Newtonian mechanics first before we jump into Lagrangian and Hamiltonian mechanics. Uh, Definitely, if you have a strong foundation in Newtonian mechanics, it is not difficult for you to learn other things like Lagrangian and Hamiltonian approaches. Actually, um, to me, this Lagrangian and Hamiltonian mechanics, it is really confirming whatever we have been learning in Newtonian mechanics. Okay, so we have to understand like the basic idea of everything, like the concepts themselves, and after that apply them in the questions. Now after applying them in the questions, then you will actually discover the beauty of each of them. So for me myself, um, I find there's a unique feature of Lagrangian mechanics, for example, that yeah, you know, when I see certain questions, I would prefer to approach it using Lagrangian. And when I see other questions, then I would prefer to just apply simple Newton's law and just solve them. So I would say that each concept has its own uniqueness, has its own I don't know, like application in a sense. But yeah, so but most of the time I would still use Newtonian mechanics. And if I have time to check my answer, I would use Lagrangian and Hamiltonian mechanics to check. You know, usually that is what I will do. Okay, because rather than I jump into more advanced concepts straight away, and then I make a mistake along the way, and that's it. You know, I'm facing a dead end, and that will be quite demoralizing, you know, for me to even continue. So I guess, yeah, I will just start with the basic concepts first.
And I think that wraps our interview. Thank you so much again, sir, for coming.
Thank you very
And
much. Yeah, it
it
is
was a
really a
pleasure having
privilege
you.
for me. All the best for Grammarly.
Thank you.
All right.
Bye.
Thank you. Thank you. Bye bye.